Okay, so we're going to see what would happen if you would modify the equation and function. So we know what sine of x looks like. Let's see what 2 sine of x looks like. So this is how we graph it. Alright, what's sine of x at 0? 0. What's 2 times 0? 0. So sine stays there for now. Alright, what's sine of pi over 2? 1. What's 2 times 1? 2. So probably 2 there. Sine of pi equals 0. 2 times 0 equals 0. Sine of 3 pi over 2 equals -1. -1 times 2 equals -2. And 2 pi, sine of 2 pi equals 0. 0 times 2 is 0. So as you see, the graph is elongated. Let's graph it for, see if that works for cosine. Alright, cosine of 0 is 1. 1 times 2 is 2. Cosine of pi over 2 is 0. 0 times 2 is 0. Cosine of pi is -1. -1 times 2 is -2. Cosine of 3 over 2 is 0. 0 times 2 is 0. Cosine of 2 pi is 1. 1 times 2 is 2. So this is also elongated. So this is because of something called the amplitude. The amplitude. If we wrote a function like this can be any function. Alright, sorry. And all these letters right here stand for variables. The A would stand for amplitude. The amplitude is measured by the distance between the two maximum points divided by 2. So the distance between 2 and -2 is 4 divided by 2 equals 2. That's actually the absolute value of the difference. So that's how you graph it by. That's how you determine amplitude by hand. But how do you determine it by equation? That's simple. It's the absolute value of A. You see here, 2 sine of x. This would be A. So the amplitude is 2. Same thing over here. 2 cos of x. The amplitude is 2. A is 2, so the amplitude is 2.